Now the next question is question number 3. Find second derivative or y2. Okay, we have first part x square plus y square is equal to a square. Solution. First we differentiate this given expression with respect to x. So differentiate with respect to x the given expression. So by using power rule, that will become 2x plus the derivative of y square will be 2y and then derivative of y, which will become y1. And on right hand side, due to the constant term of a square, the derivative will become 0. So we have 2y y1 is equal to minus 2x, and y1 will become minus 2x over 2y, and this 2 will be cancelled out. So we have y1 is equal to minus x over y. So this is first derivative of the given expression. Now again differentiate with respect to x. Differentiate with respect to x. We have second derivative y2, which is equal to, so right hand side we will differentiate by using our quotient theorem. So that will become y square in the denominator, y will be as it is, and the derivative of x will become 1, minus x will be as it is, and derivative of y, which is dy by dx, can be written as y1. So y2 is equal to, this minus will be as it is, y into 1 is y minus x, and the value of y1, here we have y1, we can say this one is 1. So from 1 we have the value of y1 is equal to minus x over y, which we substituted here. Now by simplifying, that will become y2 is equal to, this y square will be as it is, y minus and minus will be plus, x square, x into x will be x square divided by y. So now taking LCM in the numerator, that is y, and that will become y square plus x square and whole divided by y square. And y2, the second derivative, is equal to minus this x square plus y square, and this y will be multiplying to this y square will become y cube. But we have in the starting condition that x square plus y square is equal to a square. So we can write it as y2 is equal to minus a square, as we have x square plus y square is equal to a square. So just put the value of x square plus y square, a square, and that will become the second derivative of the given expression is minus a square over y cube. And the next part is x cube minus y cube is equal to a cube. Almost same question, just we have power 3 instead of 2. So again using the same procedure, we can find our second derivative as differentiate with respect to x, that will become 3x square, and derivative of minus y cube will be 3y square, and then derivative of y will become y1. This is actually like the derivative of x cube will be 3x square minus, and derivative of y cube by using power rule, that will become 3y raised to the power 3 minus 1, and then derivative of this y with respect to x is equal to, a is the constant term, so derivative of a cube will be 0. Now we have 3x square minus 3y square, and dy by dx can be written as y1, which is actually first derivative. Now minus 3y square y1 is equal to minus 3x square, and we have y1 is equal to minus 3x square divided by this minus 3y square. This minus 3 will be cancelled out. We have y1 is equal to x square divided by y square. Now again differentiate with respect to x to find second derivative, which is y2. So this is actually differentiation with respect to x. We have differentiate with respect to x. So by using quotient theorem, that will become y square d by dx of x square minus x square will be as it is, and then derivative will apply on y square. So just using our formula of power theorem, that is 2x, and derivative of y square will be 2y. Like this, we have first using use power theorem, that is 2y, and then derivative of y, which is actually y1. Again we can give it to the number, say y1. So y1 is actually x square divided by y square. Just substitute this value against this y1, which is x square over y square, and the remaining portion is as it is, like 2x into y square minus 2x square into y, and y1 is x square over y square, and whole divided by y4. Now just simplifying by taking an LCM or cancellation some terms, this y will be cancelled out to this y square. Just we have y, and x square into x square will be x4. Now taking LCM in the numerator, we have 2xy cube minus 2x4 divided by y and whole divided by this y4. Now this y will be multiplying to this y4 will become y5, and minus 2x can be taken as a common factor. From the numerator we have x cube minus y cube, but again we have x cube minus y cube is equal to a cube, so just put the value of x cube minus y cube. So this is our required second derivative. We can mention here x cube minus y cube is equal to a cube. So just using this value we have x cube minus y cube is equal to a cube. Now the next part, x is equal to a cos theta, y is equal to a sin theta. We have to find second derivative. Solution as given, x is equal to a cos theta. As x is the function of theta, so x is depending upon theta. To calculate the change, we have to differentiate this x with respect to this theta. Now differentiate with respect to theta, so that will become dx by d theta is equal to, the derivative of cos theta is sin theta with minus sign, so minus a sin theta is the derivative of a cos theta. And as y is equal to a sin theta, again differentiate with respect to theta, we have dy by d theta is equal to a cos theta. By using our chain rule, dy by dx is equal to dy by d theta into d theta by dx. So just put the value of dy by d theta, which is a cos theta, like this, and d theta by dx, we have here dx by d theta. And to put the value of d theta by dx, we just have to take this dx by d theta in the reciprocal form, which is minus 1 over a sin theta. So our first derivative y1 will become minus cot theta or cotangent theta by cancellation this a. This is our first derivative. Now to find our second derivative y2, as y1 is actually dy by dx, this is actually dy by dx, and the second derivative is actually d2y by dx square. So just to calculate our second derivative, we have to differentiate with respect to x instead of this theta. Although this y1 is looking to be a function of theta, but to find second derivative or d2y by dx square, we have to differentiate this y1 with respect to x instead of this theta. So we can write it here, differentiate with respect to x. So the left hand side will become y2 is equal to, this minus will be as it is, and derivative of cot is actually minus cosecant square theta, and then we have to differentiate this theta with respect to x. So that is actually of the form y2 is equal to minus cosecant square theta and then d theta by dx, as we are going to calculate differentiation with respect to x. So at the end we have to calculate the derivative of the angle, which is theta. Now to differentiate with respect to x, that is of the form like d theta by dx, but we have here dx by d theta, so put the value of d theta by dx by taking reciprocal of dx by d theta. So that is actually minus cosecant square theta is as it is, and the value of d theta by dx is minus 1 over a sin theta. Now y2 is equal to, this cosecant square is actually 1 over sine, by multiplying this a sin theta is actually minus 1 over a sine cube theta, which is required second derivative of the given parametric function